Hey there, fellow space enthusiast. We're diving deep into AI and robotics and space exploration today. Your notes and articles are fascinating stuff. Clearly, you're captivated by the cosmos as much as I am.
And with good reason. It's amazing to me, the sheer speed of innovation. It really feels like we've crossed some threshold where AI and robotics, they aren't just tools anymore. They're reshaping how we interact with the universe at a fundamental level.
Okay, so we've got robots on Mars, right?
Mhm.
But these aren't like some remote-controlled rover taking baby steps.
Yeah.
We're talking millions of miles away, and these things are making decisions on the fly.
Yeah,
That autonomy blows my mind.
it's incredible, isn't it? And it changes everything in terms of efficiency. Let's just take the Mars rovers, for example. They're using AI not just for navigating around, but to actually choose research targets. They can even run experiments autonomously.
So they're like robotic scientists roaming around the red planet.
Exactly. And here's the really interesting part. They're using this type of AI called machine learning. So imagine a rover, it's analyzing a rock, it's using tools like spectroscopy to figure out what's made of, cameras to get these super detailed images, and all that data gets beamed back to Earth. But it's so much data it would take us humans, like ages, to analyze it all.
That's where the AI comes in, right? Like some kind of superpower detective.
You got it. The AI can sift through all that data so much faster than we ever could, connecting the dots, spotting these subtle patterns, even identifying what we call biosignatures, those chemical signs of past life, things we might completely miss otherwise.
Hold on. Are you saying AI could help us find evidence of life on Mars?
Well, it's certainly a possibility, and that's just one example. What I find fascinating is how this same technology is being used to unlock the secrets of our solar system in ways we could only have dreamed of before.
You've got my attention. Okay, so we've covered the AI detective work happening on Mars, but what about other corners of the cosmos? I mean, I see Artemis program notes here, humanity's big return to the moon.
Right, and AI and robotics are absolutely central to that mission. And I mean central. They're not just along for the ride, they're the advanced team, they're paving the way.
So you're talking about robots building the first lunar bases. That's like straight out of science fiction.
Well, science fiction is rapidly becoming science fact. Imagine this. Robots using 3D printing technology to construct habitats out of lunar regolith, so that's the loose dirt and rock on the moon's surface.
Wow. See, I never even considered using materials already on the moon. So we're talking a completely self-sufficient lunar outpost built by robots.
Precisely. And not just built, but maintained, expanded, you name it. The level of sophistication in these robotic systems is astonishing. It's like having a whole construction crew, but instead of needing food and rest, they run on solar power and algorithms.
Okay, this is blowing my mind. Robots are practically building our future homes in space. Incredible. But wait, I see something in my notes here about drones, too. And not just any drones, autonomous drones scouting out other planets and moons.
You're right. We're not talking about your everyday drones here.
Yeah.
These are highly specialized, incredibly sophisticated machines designed to withstand the harshest environments imaginable.
Wow.
Imagine a drone navigating the icy plains of Jupiter's moon Europa or mapping the scorching terrain of Venus.
I'm picturing these drones, like braving the intense radiation on Europa to search for signs of life in its subsurface ocean or dodging volcanic eruptions on Venus to analyze its atmosphere. It's like something straight out of a movie.
It's even more impressive than the movies because it's real. And the data these robotic explorers gather is revolutionizing our understanding of the universe. There are eyes and ears in places humans can't go yet, and they're making discoveries that are literally rewriting textbooks.
This is seriously next-level stuff.
Yeah.
It seems like AI and robotics are pushing the boundaries of what we thought was even possible in space exploration. But it's not just about sending robots to these, like, crazy extreme environments, right? It's about what we can learn from the data they're gathering, isn't it?
Precisely. And this is where it gets, I think, even more exciting.
Sure.
Take Jupiter's moon Europa, for example. It's completely shrouded in this incredibly high radiation environment, deadly for humans. But a robotic probe, no problem, it can handle it.
So we send in, like, the robotic daredevils to brave the radiation and just beam back data. What kind of data are we talking about?
We're talking about data that could unlock some of the biggest mysteries in our solar system. Imagine analyzing the chemical composition of Europa's icy surface, or even peering beneath the ice to study its vast hidden ocean. It's like searching for clues in a cosmic detective case.
And these robotic explorers, they're like our best bet at cracking a case, right? Especially since we can't send humans into those harsh environments, not yet anyway.
Exactly. And it's not just Europa. Think about Venus. Its surface is insanely hot. I mean, hot enough to melt lead. But imagine a drone, right? Equipped with these special sensors, dipping in and out of Venus's thick atmosphere, analyzing its composition, studying its volcanic activity.
It's amazing to think that these robots aren't just exploring. They're essentially extending our senses to these distant worlds. It's like we're right there with them, experiencing the wonders and dangers firsthand, all from the comfort of our own planet.
It truly is remarkable. And the discoveries we're making are rewriting our understanding of planetary science. For example, data gathered by the Juno spacecraft, that's the one exploring Jupiter, has challenged our previous assumptions about the planet's atmosphere and core.
So we're not just learning about other planets, we're rethinking what we thought we knew about our own solar system.
Yeah.
That's incredible. This all sounds incredibly complex, though. Like, how do we even begin to design and build robots capable of not just surviving, but, working in such crazy, harsh environments?
That's a great question. And it highlights another fascinating aspect of this whole field, the incredible engineering challenges. These robots, they aren't just your off-the-shelf machines. These are custom-built marvels of technology, designed to withstand extreme temperatures, radiation, the vacuum of space.
Okay, so we're talking like super robust materials, cutting-edge sensors, maybe even some kind of self-repair mechanisms.
Absolutely. And don't forget about the power source. We can't just, plug these robots into a wall outlet on Mars, right?
Right. So solar panels for planets closer to the sun, maybe like nuclear batteries for missions further out.
Exactly. Every single detail matters. The type of wheels on a rover, the shielding around its electronics, it all has to be meticulously planned, rigorously tested. It's a real testament to human ingenuity.
It sounds like these missions require massive collaborative efforts, bringing together like the best and brightest from all sorts of fields, engineers, programmers, scientists.
You're absolutely right. And that's another fascinating aspect of this field. The spirit of collaboration. Space exploration is a global endeavor, often requiring the combined expertise of, multiple countries, multiple organizations.
It's incredible to think about all these brilliant minds coming together, pushing the boundaries of what's possible.
Yeah.
This really is like a golden age of space exploration, isn't it?
It certainly feels that way. And it's important to remember that this is just the beginning. As AI and robotics continue to advance, who knows what incredible discoveries await us in the vast expanse of the cosmos.
You're right. This is just the tip of the iceberg. But before we get too far ahead of ourselves, let's bring it back down to Earth for a moment, at least figuratively.
Okay.
We've talked about the what of AI and robotics in space, but what about the why? Why is all of this so important?
That's a profound question, and I think it goes beyond just the pursuit of knowledge, although that's certainly a huge part of it. Space exploration, I think, at its core is about understanding our place in the universe, right? It's about answering these big questions, the ones that have captivated humanity for millennia. Where do we come from? Are we alone?
Those are big questions. Yeah. And it sounds like AI and robotics are giving us new tools to at least try to find some answers. But it's not just about, existential pondering, right? There are also practical benefits to space exploration too, right?
Absolutely. Space exploration has driven countless technological innovations that we all benefit from every single day. From GPS navigation to satellite communications to advancements in material science, medical imaging, you name it, these all stem from space exploration.
It's amazing to think that exploring the cosmos has led to so many advancements here on Earth. It really highlights how interconnected science and technology are,
Precisely. And with AI and robotics playing, an increasingly vital role, who knows what future innovations await us? It's an exciting time to be looking up at the stars, wouldn't you say?
Absolutely. And it really does feel like we're on the cusp of like a whole new era of discovery.
Yeah.
But with all this talk about pushing boundaries, I can't help but wonder, what is the next big leap? What's the next frontier in space exploration?
It's a question that, sparks the imagination, doesn't it? What lies beyond the familiar planets and moons? Connecting this to the bigger picture, many scientists believe that the search for life beyond Earth, that'll be the driving force behind the next wave of space exploration.
Okay, so we're talking about seeking out those elusive biosignatures, those chemical hints that might point to life on other planets or moons. But how do we even choose where to look first? I mean, the universe is a pretty big place.
Right. That's where AI and robotics, they become even more crucial. Imagine this. A whole fleet of autonomous probes, each one equipped with these advanced AI systems, capable of analyzing these huge, vast amounts of data in real time. and then they're dispatched to different corners of our galaxy.
Ah,
They could scan distant planets looking for signs of life, analyze their atmospheres for those biosignatures we talked about. They could even search for, get this, technosignatures.
technosignatures. Okay, now you got to explain that one. What are technosignatures?
So technosignatures are evidence of advanced alien civilizations.
Whoa, hold on. Are we talking about like searching for alien megastructures or something?
It's not as far-fetched as it sounds. Imagine a civilization, right? Way more advanced than ours, capable of building structures on a scale that just dwarfs anything we can even imagine right now. These structures, they could emit these really unique energy signatures detectable across interstellar distances, and that's what we're looking for.
Okay, so you're saying AI could be the key to finding proof that we are not alone in the universe. That's mind-blowing.
It's a very real possibility. And just imagine the implications of a discovery like that. It would
Right.
fundamentally change, I think, how we view ourselves, our place in the cosmos.
No doubt. It would be absolutely paradigm shifting. But let's just say, hypothetically, we do find evidence of alien life, or even like, a whole advanced civilization. What then? What happens next?
That's the big question, isn't it? And there's no easy answer. That's probably a topic for a whole other deep dive. But it does raise some pretty important ethical and philosophical considerations. Like, how do we even approach contact? What are the implications for humanity?
Mhm.
You know?
It's both exhilarating and, honestly, a little daunting to even think about. But one thing's for sure, with AI and robotics at our side, the future of space exploration is filled with some seriously amazing possibilities.
I completely agree. And as we continue to peer deeper into the universe, armed with these incredible tools, we're bound to make discoveries that, well, they'll amaze and inspire generations to come. Who knows what wonders are waiting for us out there, just beyond our current understanding. It's an invitation to keep exploring, to keep asking questions, to keep reaching for the stars. And I, for one, can't wait to see what we find.